Graphing quadratic equations with shifts requires us to be able to identify the vertex form. So the vertex form of a quadratic equation will be f of x, or it might be replaced with y, equals a times the quantity x minus h squared plus k. Not all quadratics are in this form, but if they are, then you can graph them with the strategies from this video. First, let's identify what the graph of just x squared looks like. You've spent some time already graphing x squared, and so you should know that you could create a table of values, x and y, and use any x value that you desire, though I recommend using 0 for an x value and then going up and down 1 to have -2, -1, 0, 1, and 2. And then you would substitute those in for x and figure out your y values are 4, 1, 0, 1, and 4 because you have to square all of your x values, and those that were negative x values, when squared, will become positive y values. And the graph looks like this picture on the right, where a vertex is at 0, 0. And if we were to plot those 4 other points, it would create the U shape to a parabola that opens up. Now that we have that foundational understanding, let's move on to actually graphing with shifts. First item that I want to take a look at is the value in front of the quantity or in front of x. This value is referred to as a for the amplitude. If your a value is negative, then the graph is going to flip over the x-axis. So let's look at a pretty basic function that has a negative in front of the x. Here you'll see that it just says negative x squared. So we have to know that this means -1 multiplied with x squared. So that tells us that the a value is -1. And we take our standard graph of x squared and we flip this over the x-axis. Now, since we know that foundational graph had a vertex at 0, 0, when we flip it over the x-axis, it's still at 0, 0. The point that was at -1, 1 is now down at -1, -1. Similarly, the point that was at -2, positive 4, is now down at -2, -4. We can do the same thing to the first quadrant, and it lands over in the fourth quadrant. We can see from this graph that the vertex is at 0, 0, and we have an axis of symmetry that would go through that vertex with the equation x equals 0, x equaling the x value or coordinate on the vertex. And that's how I would graph f of x equals -x squared. In the second equation, we're going to have h of x equals negative multiplied with the quantity x plus 1 squared plus 3. So you'll notice this is a more complicated version of the vertex formula, and we need to identify what h and k are. So let's begin with noticing that in the vertex form, h is the value that is either added or subtracted with x, and k is the value outside of the quantity that's either added or subtracted. Now, if the value h, it'll shift your graph horizontally, meaning left or right. If your h had equaled 3, then you're going to shift your graph right 3 units. And if your k value is -2, then you're going to move the graph down 2 units because k shifts the graph vertically, up or down. Let's identify all our pieces in this function. h of x equals negative times the quantity x plus 1 squared plus 3. First, I'm going to identify that a equals -1. That tells me I'm going to flip my graph over the x-axis. The h value is found inside the parenthesis, and the h value is always going to be opposite symbol of what you see in the parenthesis. Here it's +1, so we use -1. That tells us that we're going to move left 1 value. K equals 3, which tells us we're going to move up 3 values or 3 units. And we always begin with the basic function of x squared. I like to first move my vertex of this x squared. So let's move it left 1 and up 3. That tells me my vertex is at -1, +3. You'll notice those are the same values that h and k were. It also tells me that my axis of symmetry is x equals -1. And I'm going to go ahead and put that in now. Going back to the a value, it had said to flip the graph over the x-axis. But we've already moved our vertex, so we instead just imagine flipping it upside down so the graph opens down. From our vertex, we're going to go left 1 and down 1. From our vertex again, we'll go right 1 and down 1. This is going to create the general shape of our parabola. Going back to the vertex, I'll go left 2 and down 4. Then back to the vertex, right 2 and down 4. This is called graphing by shifting, because you're shifting your vertex and you're shifting your points. The third and last example reads g of x equals x minus 5 squared minus 4. I first identify that a equals a +1, since there's no number or symbol in front of the parenthesis. That means this graph will open up like it normally does with just the graph of x squared. The h value is +5. Remember, you always take opposite of whatever symbol is in the parenthesis. So we'll be moving our vertex right 5. The k value is -4. That means we'll move the vertex down 4. And our vertex will end up being at the ordered pair 5, -4. And we know this graph opens up. So from our vertex, we can go right 1 and up 1. We can also go left 1 and up 1. And then going back to the vertex, right 2 and up 4. Or left 2 and up 4. You should always have a symmetric graph, and the axis of symmetry helps us see that symmetry. The axis of symmetry in this case is x equals 5, because the x value of our vertex is 5.